Hello folks, welcome to a new video. So in the last video we discussed about congestion control and before that we also talked about flow control. So what we are talking right now is about mostly limitations and stuff, like how to handle the limits and everything, because everything is in like the world is of course not ideal and they have like limited amount of resources that they can use and allocate. So there is bound to be some limit to it, and there needs to be some way to handle that limit as well. So since we are talking about limitations, I thought it would be a good idea to include limitations with IP addresses as well within like the same context itself. So yeah, here we are with limitations of IP. So from what we discussed in the previous videos, I think when we discussed IP address, what we discussed was like it's a 32-bit number sort of a thing, where like each part before the dot is like a 8-bit number, and so 8-bit is as in it can have maximum of 255 values if you know binary system. And even if you don't know, just remember that it can go up to 255. It cannot go, every number can go to 255, it cannot go more than that. So that's the basics of IP. 8-bit numbers, like group of 4 8-bit numbers, 32-bit long, and every like part can go up to 255. That's all. So here if you can guess, the limitation would be what? Basically, there is a chance that we might run out of unique IP addresses. Like we discussed, IP address is like an identifier for a device, if you remember. So every device will be allocated an IP address. It's not like MAC address, but yeah, sort of like it's used to identify devices over the internet. But from the very first sound of it, it feels like it will be unique for all the devices. But if that's the case, we cannot like this combination of 4 groups of 8-bit numbers can have like some 4 billion values or something. So if the number of devices in this world were to cross 4 billion, we won't be able to allocate a unique IP address to all of like anything after that. So that is a problem, that is a limitation that we need to tackle. So we will talk about that here. So when we think about the problem, what is the first thing that comes to the mind? The first thing that comes to mind is, why don't we increase the range? Basic thing, like if range is the problem, then we can just increase the range, right? But what's stopping us from doing that? We'll come to that, but that solution has a name and it's called IPv6. I just bring it up for now. Okay, so like we discussed, IPv4 is 32-bit and numbers are decimal, as in like if you let's say this is 1 bit, okay. IPv4, every group will have 8 such bits. 8 such bits. Yeah, every group will have 8 such bits, and like every bit can have a 1 or 0 value. So that's what. But the thing is, like here we are using just decimal for representation. The system is decimal. We are not using something else. But what IPv6 does is, it's a 128-bit long like element sort of a thing. So of course the range is very high, and for notation it uses hexadecimal. Like it won't look something like we have here. It will have like hexadecimal is basically another number system like decimal system. Decimal system, what are the unique values that it can have? It can have unique values from 0 to 9. Hexadecimal can have more unique values. After 0 to 9, it has A, B, C, D, E and stuff. So basically hexadecimal will have more unique values, since it's called base 16 and base 10 sort of a thing. Like base 10 as in everything is like based around the number 10, and after that like the pattern sort of repeats. For hexadecimal is 16. So that's the basic thing. So here the basic thing that we need to keep in mind for understanding is, hexadecimal has like more values of number that we can use here, and that's so on. So I'll just maybe like how do I represent? Maybe something like A, E, colon, D, F sort of a thing, and so on. Like it will keep on going like this. This sort of a thing. When you see notations like this, these are hexadecimal notations. But you can always convert them back to decimal, but that's out of the scope for this video. Just remember that what IPv6 is trying to do is, it will just increase the range of whatever range of how many numbers IP can cover, so that we can encompass more devices. And it's like a very huge number. I don't remember it. It was like 36 zeros after some digit or something, like very huge. So this was the solution that one proposed. But one issue is every router and stuff in the world is programmed to use IPv4, like we discussed, standard sort of a thing. So IPv4 is like the guys back then discussed that the world might not cross 4 billion devices someday. So maybe it makes sense to keep the standard as IPv4. Maybe it keeps sense to keep the length of this as 32-bit. But today that's not the case. Today, every other day, like new devices are coming up and stuff. So we need to allocate them IPs and everything. So it's running out eventually. So some people came up with IPv6. They told that, okay, let's increase the range if range is the issue. But then again, we already like launched so many devices on IPv4. So once like those devices need to be reprogrammed for IPv6, and so like God knows how many devices we need to go on doing that. So that would be sort of an overkill. So we haven't quite really totally migrated till IPv6. Somewhere, someplace, maybe like on internet and stuff, these are adopted. But on a wide range of things, we haven't really yet migrated to IPv6. We are mostly still on IPv4. Another solution that comes to mind is like, okay, so what we cannot increase the range, right? So what else can we do? Like how to increase? What if we group the devices? Like if that's a proposal, what if we have like one IP address, and within that IP address we have multiple IP addresses, if that makes sense. So let's say this is one IP address, and within that we have multiple IP addresses, and it can keep on going as many as we want. Maybe like it will have a range, of course, but this will be like, this is somewhat like expanding over this only. Like let's say the book rec sort of a thing that we took an example. Let's say is the category, these are the books, and so on. So what if we use some IP to generate this sort of categories, and based on like under those categories we can group more devices which will have their own IPs and stuff, but like everything needs to go through this. So that would increase the range, right? So rather than allocating private IP address to all of them, what we do is we tend to group them. And like, let's say this is the router. Router will act as their path to the external internet. Router will have a public IP address, which will take a toll on the total number of devices and stuff that we talked about. It will have a public IP address, and it will have it will help the devices in its own network to communicate among themselves as well, so that they don't need to communicate via the public IP address, and like they don't need to be assigned one specific IP address for every device. So basically we are grouping them so that we can use one IP address for like maybe tens or 20s or so on devices in the public domain, not in the private domain. This is the private domain, like communication among these devices and stuff. This is the private network. We call it the private network. But for the wide internet, the public domain, what would be exposed is the public IP address of the router. So this will have two IP addresses, public and private IP addresses. So private IP addresses is like within this network itself, and public is like when it needs to push something outside to the World Wide Web, then it would use the public IP address for that. So imagine it like to be a home sort of a thing, where maybe this is the like doorway or something, and these are the family members, or maybe this is something that they use to communicate with the outside world and that sort of a thing. But internally also they can communicate, and they don't need a specific unique IP address for that. So that won't take a toll on this, because since it's not unique, it can be like let's say there are two different networks are there, but it is likely that somehow if the public IP addresses of those two networks are different, private can be like not necessarily it needs to be different and stuff, because either way they aren't using the private IP address to communicate with the internet, so there won't be any clash and stuff. So everything that goes to the public internet has to go through like the public IP address itself, and that needs to be unique. Inside their own network, they can do whatever they want. That's the basic concept of it. And yeah, this is something. This thing is called NAT. We handle it using something called NAT, and we'll come to that in the next video. I think I won't dive deep into it as of now. Basically, just remember that it's called NAT, and we'll discuss in the next video. So how does the whole communication takes place? We'll walk through the whole thing. Let's say there are two public networks, and some device from this network wants to talk to some device from the other network. How would that communication take place? We'll discuss them in the next video. So yeah, that should be it for this video, I guess. I hope I was able to explain the limitations with IP well. If you have anything, you can always ask in the comments, and if you like my content, of course you can like, subscribe and stuff, and share and everything. Okay, see you guys. Good day. Bye.